Hey guys, today we're going to take a look at what we call summation notation or sigma notation. First of all, this is just a way of rewriting things to make them more simple and more straightforward. It's actually not nearly as complicated as it looks. Often we look and see these fancy symbols and think that they mean something intimidating, but this one's actually fairly straightforward. So the symbol here is the Greek letter, it's the Greek letter sigma. All right, it's a capital sigma, and also it's used to designate this summation notation. Okay, summation meaning addition. All right, so for example, suppose an experimenter measured the performance of 6 subjects on a memory task. So subject 1 is referred to as x1, subject 2 is x2, etc. So there's the scores. So what we would do here, if we were going to, if we write this out here, we're saying, so the symbol here, okay, that just means add up the values of xi starting at I equals 1 and going up to I equals 6. All right? So in other words, it just means x1 plus x2 plus yada 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 plus x6. All right? Which is fairly straightforward. It's just going to be 7 plus 6 plus 4 plus 2 plus 8 plus 5. All right, and we just add them up the way you would normally do it, and you get 32, and that's it. So it's just a condensed way of saying add up all these numbers. Now this is a fairly short chart here, but you can see how this would be an easy way of writing it if I wanted you to add up, 200 rows or something like that. All right, so the way you would read it, and there's a little error here I noticed. Some people will say sum the values x1 through 2. You should actually say sum of. Sum's not actually a verb, but whatever, it's fine. So in order to make the formula more general, often what we'll do is we'll do this where we put an n on top, and that just means add them up until you get to the last one. So if you've got that capital N on top, it just means keep going until you run out. That's all it is. All right. So for example, we're going to add up all the household in a bunch of people's houses. So let's say we'll have Paul, who has 4. We'll have Ringo, who has 5 people living in his house. We will have George, who has 3 people. We will have John, who has, let's go 4. And then let's go Bert. And Bert has 3 people. And then we'll go Ernie. And Ernie has 6 people. And then we'll go Mo. And Mo has 3. Curly has 4. And Larry has 5, and Shemp has 3. Okay, so the point is that we're just gonna, if we say this, if we've got this written, it's just saying add up xi, so each piece of data, starting from the first piece of data going all the way up to the last piece of data, whatever that may be, and find out what you get. So we would just do 4 plus 5 plus 3 plus 4 plus 3 plus 6 plus 3 plus 4 plus 5 plus 3, and it would equal 40. Okay, so that's that. All right, so I know what you're thinking. You're thinking, please make this a little bit more complicated, which of course we're going to do. So we're going to use these with exponents because it's not just going to have you add up all the terms. We wouldn't need to come up with something this complicated or seemingly complicated just to add up a bunch of numbers. We can do things with those numbers. So one of the things you'll see is if we look at this one, what I want you to do is I want you to take each term and I want you to square it, and then I want you to add it up. Okay, so in this case you would have 4 squared plus 5 squared plus 3 squared plus yada yada yada. We'll go 4 squared. I better write it all out this time because I'm actually going to have to do it here. 3 squared plus 6 squared plus 3 squared plus 4 squared plus 5 squared. Whoops, that's a cubed. Squared plus 3 squared. Okay, so you can see we're just taking every piece of data, and before we add it up, we're just going to square it, all right? And so that'll give us 170, all right? So now, I told you to be, in more general terms, we'll just put the n at the top. Sometimes what we'll actually do, whoops, I don't know what I did there. I don't know what's going on. All right. Nope. It's just messed up. All right. You can see here I haven't written the I haven't written the n. This just means add them all up. It's kind of a lazy way to do it. And if you're doing, depending on how you're using this, what you're using it for, that may be okay. In the world of statistics, it's often considered fine because it just means add up all the data pieces. If, however, you're using this notation in something like calculus, often that I equals and the n on top will be important, okay? So sometimes you'll get away without writing them. In actual fact, in this class, most of the time we won't write them because, as I say, in the world of statistics, this is kind of how it's done. It's just when you're doing sort of, whether it's calculus or physics, something like that, that's just a little bit more computation heavy, it can be important to do that, all right? So the other thing that's really important is we need to see the difference between that guy and that guy. So you can see there's brackets around the sigma xi, all right? These two things are completely different, and this is something that people do make mistakes on. It comes up often because often in the same formula you'll have both of these two things. And what this one here means is it means I want you to add them all up and then square it, as opposed to this one here, which means square them and then add them up. And you'll get very different answers, as you'll see. So if I were to do this one, let's get back on the screen. So I would just add them all up. So 4 plus 5 plus dot, 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 plus, and it went up to 3, I think. Okay? And then we square it. Okay? So you would actually get that 40 that we got before, and then you would just square it, which gets you 1,600. Okay? Which obviously 1,600 is considerably larger than 170. So it's very important to see the two differences between those. Okay? Another thing that will often happen is that we will have to use multiple variables, and that's fine. So for instance, we've got this table here, and we've got 4 different teachers, although my teaching staff is outdated. I should change this one to somebody else. Let's change that to Mr. Brake. Although, yeah, whatever, that's fine. I suppose if I use this video next year, then it could be completely different. Who knows? Anyway, so each teacher is associated with 2 different variables. I've recorded 2 different scores for each of them. Okay, so now in my formula, I have sigma xy. Okay, and of course I mean multiplication here. And so what you're going to have to do is you're going to have to take both variables and multiply them before you add them up. All right, so we would have, let me just zoom in. So we'd have 5 times 7 for Mr. Hall, plus 3 times 8 for Mr. Brake, 9 times 3 for Cavisto, 10 times 6 for Miss Ellis. Okay? And so then you would just do it, using your normal bed mass. We'd have 35 plus 24, plus, and we got 27 plus 60. All right, and then you just add those numbers up, and we will get 92. All right, that's it. All right. So the last thing that we'll often do is sometimes we'll give you another number in the formula. Sometimes it's constant, sometimes it's a number that you've calculated otherwise. Often it's something like the mean or the average that you have to subtract from each one, or the standard deviation, which we will learn about in a future lesson. So whatever it is, it'll just be, this will be your formula. Your formula will look something like that. And I'll tell you, well, m is equal to 3. And maybe you had to calculate that elsewhere, but it'll just show up. And so you just go through and you just go one at a time. So, and I'm using the same data set here with the 4 teachers. So it's going to be 5 minus 3 plus 3 minus 3 plus, and the brackets aren't strictly necessary here, but I like to separate my pieces of data. And we just subtract 3 from each piece of data, okay? And then you can do the subtraction. We get 2 plus 0 plus 6 plus 7, okay, which is equal to 15. Okay, and that's it. All right. Obviously, this one's the exact same, except that you're adding, and we're using the other data set. So we would just have equals, I'm going to get lazy here. No, I'm not. I won't do that. So we'll have 7 plus 2 plus 8 plus 2 plus 9 plus 2 plus 6 plus 2. Okay, and some of you may look at this and be like, well, why didn't you just multiply the 2 by 4 and then add it and stuff like that? And yeah, like that could be easier, but the thing is, because of how the formulas are often used, sometimes that's not necessarily the easiest way because that number will change. Maybe you had to calculate it. There's a lot of scenarios where it's not necessarily the best way to do it. Okay, but the other thing is that we will learn how to use spreadsheets to do a lot of this, and so that's where the sigma notation comes in really handy, is when you program the formula into this system, and then you just input your data set, and then it does all the hard work for you. Okay, so we'll do one last one here, where we're going to subtract the 5, then square it, then add it, and that's, again, that's important. These brackets here, these brackets are, well, I need a those brackets, oh my goodness, all right, whatever. You see the brackets. They're on the inside, they're not outside of that sigma, and so that's why we're going to square everything first and then add them up, as opposed to adding them up and then squaring it, okay? So we'll just get 5 minus 5, and then we square it, and then we add it to the next piece of data, which was 2 minus 5, and then we square it. And this one might seem needlessly complicated, but a lot of the formulas are going to look a lot like this. Some of them will, again, as I say, they'll actually be much more intense than this. And that's why it becomes important to learn how to use the spreadsheets to do all the heavy lifting for you. It's not necessarily hard math. It's not necessarily complicated calculations. It's just a lot, and especially if your data set, like I'm giving you really small data sets here. You're not going to be working with 4 variables usually. Typically you're going to deal with, you know, at least 20, maybe more, probably more. Okay. Anyway, so we go through, we get 0 plus 9 plus 16 plus 25, and that is going to give us 45. Okay, and that's it. All right, until next time, go Sabres.